ChatGPT came along, and something is very important in this slide. Here, let me show you something. This slide, okay, and this slide. The fundamental difference is this. Until ChatGPT revealed it to the world, AI was all about perception, natural language understanding, computer vision, speech recognition. It's all about perception and detection. This was the first time the world saw a generative AI. It produced tokens, one token at a time. And those tokens were words. Some of the tokens, of course, could now be images, or charts, or tables, songs, words, speech, videos. Those tokens could be anything. Anything that you could learn the meaning of. It could be tokens of chemicals, tokens of proteins, genes. You saw earlier in Earth 2, we were generating tokens of the weather. We can learn physics. If you can learn physics, you could teach an AI model physics. The AI model could learn the meaning of physics, and it can generate physics. We were scaling down to 1 kilometer, not by using filtering, it was generating. And so we can use this method to generate tokens for almost anything of value. We can generate steering wheel control for a car. We can generate articulation for a robotic arm. Everything that we can learn, we can now generate. We have now arrived not at the AI era, but a generative AI era. But what's really important is this. This computer that started out as a supercomputer has now evolved into a data center, and it produces one thing. It produces tokens. It's an AI factory. This AI factory is generating, creating, producing something of great value, a new commodity. In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry.
A lot of the clips that you're going to see here, they look like animation. They look like something that in the past we would think of as cartoons, something that somebody drew or animated on a computer. But that's not quite what it is.
What is generative AI? What is its impact on our industry and on every industry? A blueprint for how we will go forward and engage this incredible opportunity. And what's coming next? Generative AI and its impact, our blueprint, and what comes next. These are really, really exciting times. A restart of our computer industry, an industry that you have forged, an industry that you have created, and now you're prepared for the next major journey. But before we start, NVIDIA lives at the intersection of computer graphics, simulations, and artificial intelligence. This is our soul. Everything that I show you today is simulation. It's math, it's science, it's computer science, it's amazing computer architecture. None of it's animated, and it's all homemade. This is NVIDIA Soul, and we put it all into this virtual world we called Omniverse. Remember, the idea that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, NVIDIA Inference Microservices. Now, what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism. Distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realized that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it contains an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you could literally chat with this box. You download this NIM, and you can talk to it. So long as you have CUDA on your computer, which is now, of course, everywhere. It's in every cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, you have an AI, and you can chat with it like ChatGPT. All of the software is now integrated. 400 dependencies, all integrated into one. We tested this NIM, each one of these pre-trained models, against our entire install base that's in the cloud, all the different versions of Pascal and Amperes and Hoppers and all kinds of different versions. I even forget some. NIMS, incredible invention. This is one of my favorites. And of course, as you know, NIMS is a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a very, very important part of our software. It's a we now have the ability to create large language models and pre-trained models of all kinds. And we have all of these various versions, whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare, digital biology. We have versions that are digital humans that I'll talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized. It's available there for you to try. And you can even take it with you. It's available to you for free. And so you could run it in the cloud, run it in any cloud. You could download this container, put it into your own data center, and you could host it, make it available for your customers. We have, as I mentioned, all kinds of different domains. Physics, some of it is for semantic retrieval called RAGs, vision languages, all kinds of different languages. And the way that you use it is connecting these microservices into large applications. One of the most important applications in the coming future, of course, is customer service agents. Customer service agents are necessary in just about every single industry. It represents trillions of dollars of customer service around the world. Nurses are customer service agents in some ways. Some of them are non-prescription or non-diagnostics based nurses are essentially customer service. Customer service for retail, for quick service foods, financial services, insurance, just tens and tens of millions of customer service can now be augmented by language models and augmented by AI. And so these boxes that you see are basically NIMS. Some of the NIMS are reasoning agents. Given a task, figure out what the mission is, break it down into a plan. Some of the NIMS retrieve information. Some of the NIMS might go and do search. Some of the NIMS might use a tool like cuOpt that I was talking about earlier. It could use a tool that could be running on SAP. And so it has to learn a particular language called ABAP. Maybe some NIMS have to do SQL queries. And so all of these NIMS are experts that are now assembled as a team. So what's happening? The application layer has been changed. What used to be applications written with instructions are now applications that are assembling teams of AIs. Very few people know how to write programs. Almost everybody knows how to break down a problem and assemble teams. Every company, I believe, in the future will have a large collection of NIMS, and you would bring down the experts that you want. You connect them into a team, and you don't even have to figure out exactly how to connect them. You just give the mission to an agent, to a NIM, to figure out who to break the tasks down and who to give it to. And that central, the leader of the application, if you will, the leader of the team, would break down the task and give it to the various team members. The team members would perform their task, bring it back to the team leader. The team leader would reason about that and present an information back to you. Just like humans. This is in our near future. This is the way applications are going to look. Now, of course, we could interact with these AI services with text prompts and speech prompts. However, there are many applications where we would like to interact with what is otherwise a human-like form. We call them digital humans. NVIDIA has been working on digital human technology for some time. Let me show it to you. Digital humans has the potential of being a great interactive agent with you. They make much more engaging. They can be much more empathetic. And of course, we have to cross this incredible chasm, this uncanny chasm of realism, so that the digital humans would appear much more natural. Route planning optimization, the traveling salesman problem, incredibly complicated. People have Well, scientists have largely concluded that you needed a quantum computer to do that. We created an algorithm that runs on accelerated computing that runs lightning fast. 23 world records. We hold every single major world record today. cuQuantum is an emulation system for a quantum computer. If you want to design a quantum computer, you need a simulator to do so. If you want to design quantum algorithms, you need a quantum emulator to do so. How would you do that? How would you design these quantum computers, create these quantum algorithms, if the quantum computer doesn't exist? Well, you use the fastest computer in the world that exists today. And we call it, of course, NVIDIA CUDA. And on that, we have an emulator that simulates quantum computers. It is used by several 100,000 researchers around the world. We believe that by reducing the cost of computing incredibly, the market, developers, scientists, inventors will continue to discover new algorithms that consume more and more and more computing, so that one day something happens, that a phase shift happens, that the marginal cost of computing is so low that a new way of using computers emerge. In fact, that's what we're seeing now. Over the years, we have driven down the marginal cost of computing in the last 10 years in one particular algorithm by 1 million times. Well, as a result, it is now very logical and very common sense to train large language models with all of the data on the internet. Nobody thinks twice. This idea that you could create a computer that could process so much data to write its own software, the emergence of artificial intelligence was made possible because of this complete belief that if we made computing cheaper and cheaper and cheaper, somebody's going to find a great use. Well, today, CUDA has achieved the virtuous cycle. Install base is growing. Computing cost is coming down, which causes more developers to come up with more ideas, which drives more demand. And now we're in the beginning of something very, very important. But before I show you that, I want to show you what is not possible if not for the fact that we created CUDA, that we created the modern version of the modern big bang of AI, generative AI. What I'm about to show you would not be possible. This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year, but this year we made some great breakthroughs. We enabled transformers to be able to train on enormously large data sets. Well, what happened was, in the beginning, the data was human supervised. It required human labeling to train AIs. Unfortunately, there is only so much you can human label. Transformers made it possible for unsupervised learning to happen. Now, transformers just look at an enormous amount of data, or look at an enormous amount of video, or look at an enormous amount of images, and it can learn from studying an enormous amount of data, find the patterns and relationships itself. Well, the next generation of AI needs to be physically based. Most of the AIs today, don't understand the laws of physics. It's not grounded in the physical world. In order for us to generate images and videos and 3D graphics and many physics phenomenons, we need AIs that are physically based and understand the laws of physics. Well, the way that you could do that is, of course, learning from video is one source. Another way is synthetic data, simulation data. And another way is using computers to learn with each other. This is really no different than using AlphaGo, having AlphaGo play itself, self-play, and between the two capabilities, same capabilities, playing each other for a very long period of time, they emerge even smarter. And so you're going to start to see this type of AI emerging. Well, if the AI data is synthetically generated and using reinforcement learning, it stands to reason that the rate of data generation will continue to advance. And every single time data generation grows, the amount of computation that we have to offer needs to grow with it.
NVIDIA's AI senior research scientist, Dr. Jim Fan, once said that everything that moves will be automated. It will be intelligent. It will be driven by an AI system. And as you'll see here, they're not kidding around about that.
Let me talk about what's next. The next wave of AI is physical AI. AI that understands the laws of physics. AI that can work among us. And so they have to understand the world model so that they understand how to interpret the world, how to perceive the world. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks. In the future, robotics is a much more pervasive idea. Of course, when I say robotics, there's a humanoid robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic.